Hello and welcome to my YouTube channel. I am Pierre, professional engineer specialized in computer assisted design. I'm passionate about high technology and aircraft. This video showcases the functionalities of the application called Airfoil Catalog. It is the basic application in the project. It allows the user to customize, to define, and to save airfoils for other specific uses. The airfoils are separated into several categories. Let's have a quick look at each of them. This new version of the Airfoil catalog uses tabs to navigate between the 10 families of airfoils available in the application. The PACP4 airfoil family is a family of custom airfoils that may be used, for example, in turbomachinery. The user can control the leading and trailing edge angles, the thickness, and the trailing edge offset ratio. The combination of these parameters can lead to an infinity of combinations. The PACP6 airfoil family is based on the same principle as the previous family. Instead, it implements two extra parameters that allow the user to define a bump in the middle of an airfoil. This functionality might prove useful to define airfoils in wind turbines. The NACA 4 and NACA 5 airfoil families are families of airfoils that were developed by the NACA organization earlier in the 20th century. These airfoils are built from the numbers, which describe their main features such as maximum camber position, and maximum thickness. Each of the lists in either family may be filtered to ease the research of a specific shape. The circular and the parabolic families define airfoils which their camber lines respectively have circular and parabolic shapes. As these shapes are theoretically exact, they can be used to validate calculations. The Joukowsky and van der Vuuren airfoils are shapes developed by researchers in incompressible aerodynamics. They are characterized by their thin trailing edges. These shapes allowed them to validate boundary element methods for low-speed cases. The Bézier family is a family in which the user is given full control of the camber line. By clicking, control points are added and moved so the desired shape may be reached. The database family allows the user to select airfoils defined from XML files. The user can also define new airfoils or modify existing ones. This family currently includes some supercritical airfoils and other shapes taken from the literature. Here now is an overview of the main features of the application. The Airfoil catalog implements saving and loading features. This allows a user to save the selection of a particular airfoil to a file, which may be used later in other contexts. Airfoils that are not symmetrical can be reversed upside down. This feature is useful in the case where an airfoil that generates downforce is needed. The Airfoil catalog has the ability to export the geometry of an airfoil to CATIA V5. The exportation is made quick by the use of knowledge work code. Shapes may be exported as 3D geometry in the CatPart format or as 2D geometry in the CAD drawing format. For most airfoils, the catalog will display real-time information, such as the predicted zero lift angle of attack, the area, and so on. This concludes the video presentation of the Airfoil catalog. If you have questions or requests, feel free to send me an email at the address shown. Thanks for watching.